Right, our lesson today is to be able to use the Pythagorean theorem. Pythagoras was a Greek mathematician, and philosopher who discovered one of the most famous rules in mathematics. In mathematics, a rule is called a theorem. So the rule that Pythagoras discovered is called the Pythagorean theorem. The Pythagorean theorem works with right triangles, and it highlights a very special and unique relationship with right triangles. The Pythagorean theorem says that if you take a look at a right triangle, which we have here, you see the right triangle symbol. You have a leg and another leg. Your legs form the right angle of the right triangle. So your legs form the right angle. They're perpendicular to each other. The hypotenuse is the longest side of the right triangle. The Pythagorean theorem says that in any right triangle, the sum of the squares of the lengths of the legs is equal to the length of the hypotenuse. Right? In equation form, it would read a squared plus b squared is equal to c squared. And because of that relationship, we can use that equation to solve a variety of problems. All right? So let's take a look at our first example. It says find the length of the hypotenuse of the triangle. First of all, you have to make sure that it's a right triangle, and we see the right triangle symbol. We have to identify the legs here. The legs form the right angle of the right triangle, so that is your A and your B. It doesn't matter which leg is A and which leg is B, as long as C is the longest side of the right triangle. So we always start by writing our formula, which says that A squared plus B squared is equal to C squared. We replace A with one of the legs, 5, and we have to square it, and we replace B with the other leg. We have to square that, and that has to be equal to C squared. Well, we know 5 squared is 25. We know 12 squared is 144. And the sum of those two squares has to be equal to the length of side C squared. When we solve this equation, we have 25 and 144 is 169. 169 is equal to C squared. Last step here is we take the square root of both sides of that equation, and we get 13 is going to be equal to C. So we're able to find the longest side of the right triangle by using that Pythagorean theorem. All right? Let's try one more. All right? Once again, notice that we're missing the longest side, and we're given the lengths of the two legs because the two legs form the right angle here. All right? So we write our formula, A squared plus B squared is going to be equal to C squared. We simply want to replace A with one of the legs and B with the other leg that's given, right? And we have to square each of those legs, and that's got to be equal to C squared, the sum of those two, the square of the legs. 8 squared is 64. 15 squared is what? 225. That's got to be equal to C squared. 64 and 225, that's going to be what? 289. That's equal to C squared. We take the square root of both sides of that equation, and we get 17 is going to be equal to C, right? 17, and those are feet, right? I don't want to forget my labels here. All right, and that's an example of how you would use the Pythagorean theorem to find the longest side of a right triangle. All right, but suppose if we need to find one of the legs. All right, well, we still do the problem. Start off the following way by writing in the formula A squared plus B squared is going to be equal to C squared. And notice that we're given the longest side of the right triangle because that's always going to be the opposite side of the right angle, but we're missing one of the two legs that form the right angle. So when you use the formula here, you want to make sure that you replace either A or B with the leg that's given, so 2.1 squared plus B squared. All right, actually, let me do this the right way. Since we're looking for A, I'm going to square A, right, because that's what we're looking for, and we'll put the 2.1 for B. But it really doesn't matter, but we'll substitute since the variable's there, we'll do that. C squared is 2.9, or C is 2.9, and we have to square that. Now, I'm going to have to use a calculator, right, to do some of this. So I'll grab my calculator and see what this is going to look like here. All right, so when we have our calculator, we want to take 2.1 times 2.1, and that's going to give us 4.41. All right, so a squared plus 4.41 is going to be equal to, clear, let's do 2.9 times 2.9. That's going to be 8.41. All right, we solved that equation first by subtracting 4.41 from both sides of that equation. Right, that's going to be 0. So a squared is going to be equal to 8.41 minus 4.41. That's going to be 4. We take the square root of both sides of that equation, and a is going to be equal to 2 centimeters. All right, so let's try a couple of other examples where we're looking for the legs of our right triangle. All right, so here's our next example, problem number 3. I'll do over here. We'll write the formula: a squared plus b squared is going to be equal to c squared. All right, we're given a this time, 34, so 34 squared plus b squared is going to be equal to the 16 squared. All right, let's do the 34 squared times 34. That's going to be 1,156 plus b squared is going to be equal to 16 squared. That's 256. All right, we want to solve that equation for b. And then, I made a mistake there. All right, I don't know if anyone caught it, but my c has to be the longest side of the right triangle. And the reason why I could see that something was wrong was that my b was going to be negative, right? Because to solve this equation here, I would have had to subtract 1,156 from both sides of the equation. Right, and that would have given me a negative value for b, and we can't take the square root of a negative number. So I look at my work and I notice, I did not replace c with 34, right? C has to be the longest side of the right triangle, so let's fix that, right? It's always good to find the mistakes. So a squared has to be the 16 plus b squared, and that's got to be equal to my 34 squared. 16 squared we said is 256 plus b squared, that's going to be 1,156. We subtract the 256 from both sides of the equation. We wound up with b squared. It's going to be equal to 900. All right, we want to solve that equation by taking the square root of both sides of that equation, and b is going to be equal to what? 30, right? And those are yards. All right, we'll do one more example here. Change colors. All right, write our formula: a squared plus b squared is going to be equal to c squared. A squared we're looking for, but b we're given is the 9.6. That's going to be 9.6. We have to square that, and that's got to be equal to the 10.4. That's got to be squared. A squared plus, let's do 9.6 squared times 9.6, that's going to be 92.16 is equal to 10.4 squared. 10.4 times the 10.4, that's going to be 108.16. I want to solve for a, so we'll start by subtracting 92.16 from both sides of that equation. All right, that's going to give me 0 here. So I'm left with a squared is going to be equal to, what's that, 16. And then we take the square root of both sides of that equation. A is going to be equal to 4, and those are meters. All right. Now let's see, was there anything else that I wanted to go through with you guys? Let's see. The converse of the Pythagorean theorem. All right. Well, if the sides of a triangle have lengths a, b, and c such that a squared plus b squared is c squared, then the triangle is a right triangle. If you reverse the parts of the Pythagorean theorem, you have formed its converse. All right, which is simply says that if a squared plus b squared is c squared, then the triangle is a right triangle. So we use the converse of the Pythagorean theorem to prove if a triangle is a right triangle or not a right triangle. All right, so let's take a look at this example. It says the measures of three sides of a triangle are 5 inches, 12 inches, and 13 inches. Determine whether the triangle is a right triangle. So we want to know, does a squared plus b squared equal c squared? And if so, then it is a right triangle. So we have to replace a and b with the smaller sides because c has to be the longest side. So is 5 squared plus 12 squared equal to 13 squared? 5 squared is 25, 12 squared is 144. Does that equal 13 squared, which is 169? All right, and the answer is yes, right? 169 is 169, so that means yes, right? That is a right triangle if the sides are 5 inches, 12 inches, and 13 inches. All right, so let's try this a couple of times to see if triangles are right triangles or not. All right, so we always write the formula, a squared plus b squared is going to be equal to c squared, and is, let's do this, is 36 squared plus 48 squared equal to 60 squared. All right, well, let's do the math and find out. 36 times 36, that's 1,296, plus, clear, 48 times 48, that's going to be 2,304. Is that going to be equal to, what's that, 3,600 when we do 60 squared? All right, well, let's add 1,296 plus 2,304 equals, look at that, that's 3,600 is equal to 3,600. So the answer here is yes, right? That is a right triangle because a squared plus b squared is equal to c squared. Now let's try this one, right? We have to have the 4 and the 5, or the a and the b, because 7 has to be c. The largest number has to be the largest side of the right triangle. So does 4 squared plus 5 squared equal 7 squared? 4 squared is 16, 5 squared is 25. Does that equal 49? Well, 25 and 16 is what? 41. Does 41 equal 49? The answer to that is no, which means if we have a triangle with sides of 4, 7, and 5, right, it is not a right triangle. All right? Now, this next page I thought was pretty important, and I wanted to share this with you guys. Some common Pythagorean triples. The whole numbers 3, 4, and 5 are called Pythagorean triples because they satisfy the Pythagorean theorem. All right? The 3, 4, 5 triangle, I may have mentioned to you guys in passing, but the 3, 4, 5 triangle is the most common Pythagorean triple, right? Because 3 squared, which is 9, plus 4 squared, let's write that out. 3 squared plus 4 squared equals 5 squared. 3, 4, 5. It's very easy to remember. 3 squared is 9, 4 squared is 16, 5 squared is 25, right? So the 3, 4, 5 triangle is the most common Pythagorean triple, Pythagorean triangle, all right? But various forms of the 3, 4, 5 triangle, right? 6, 8, 10, because 3 times 2 is 6, 4 times 2 is 8, 5 times 2 is 10. So the 6, 8, 10 triangle is really the 3, 4, 5 triangle in disguise. And when you guys do these problems that involve the Pythagorean theorem, very often you're going to see variations of the 3, 4, 5 triangle. And if you recognize a problem, a Pythagorean problem question using the 3, 4, 5 triangle, you know what those sides are going to be. Some various form of 3, 4, and 5, right? Because if I use 6, 8, and 10, 6 squared plus 8 squared equals 10 squared. 6 squared is 36. 8 squared is 64. Does 36 and 64 equal 100? Yes. So variations of the 3, 4, 5 triangle are the most common Pythagorean triples. So if I'm filling in this table here, right, what's the missing value? Well, 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15, right? So it's a very common Pythagorean triple, all right? Now, what's another common Pythagorean triple? The 5, 12, 13. All right, 5, 12, 13 is not a 3, 4, 5 triangle, but it is a very common Pythagorean triple. And this last one here, 15 and 17, right, what side, oops, right, what would the missing side be? Well, let's figure that one out, right? Let's use this space over here using our formula. So we have a squared plus 15 squared is equal to 17 squared. A squared plus 225, that's got to be equal to 289. When we subtract 225 from both sides of that equation, we wind up with a squared is going to be equal to, what's that, 64, right? Square root of both sides, a is going to be equal to 8. So the 8, 15, 17 is another common Pythagorean triple, all right? But the most common is the 3, 4, 5 and variations of the 3, 4, 5, right? All right, that's going to be the end of our lesson. I hope that that was helpful, and you guys, good luck and do your best.